We're starting our Math 9 quiz review, okay, and the quiz is going to have 10 questions. And first I'm going to do an example and show you the question that corresponds to that example. So we'll start with this example. We want to reduce, all right, we have a quotient of two polynomials and we want to reduce this. Okay, so let's do that. So here we can factor out of the numerator. We can factor out a 6, and let's see, we can factor out x to the third and y. Okay, and what's left in parentheses, we have minus y cubed, and then we have plus 2x. All right, and then we'll cancel what we can over here. So let's divide minus 2 into 6. So here we have minus 3. We can divide x squared into x cubed, and we have x, and these y's cancel. So this reduces to minus 3x times minus y cubed plus 2x. All right, now here's the first problem that's similar to the one that you just saw. And let me pull this down a little bit. Okay, so there's number 1. So copy this down, pause the video, copy this down on the template that you got in class. If you don't have a copy of the template, you can get it from Blackboard. Okay, so now you can do problem number 1. Okay, in the second example, we're going to multiply these two rational expressions. All right, we're going to first factor and cancel what we can. So first we'll factor 9 minus x squared. So that's 3 minus x times 3 plus x. And now let's factor x squared minus 5x plus 6. That's x minus 3x minus 2. And let's pull out a 2 from 2x plus 4, and we have 2 times x plus 2. And here we can pull out a 7, and we have 7 times x plus 2. Okay, so we have some canceling. First of all, we have this x plus 2 and this x plus 2. And then we have x minus 3 and 3 minus x. And since they are in a different order, we replace with minus 1. Subtraction in a different order, right? We don't do that for an addition in a different order, just a subtraction. All right, so what do we have left in the numerator after all this canceling? We have minus 1 times 3 plus x times 2. So I'll write that as minus 2 times 3 plus x. And in the denominator, we have 7 times x minus 2. Okay, now you're ready to do question 2. So here it is. Let me just pull this down a little bit. Okay, so there's question 2. Okay, so copy it down, pause the video, copy it down, and do question 2 now. In example 3, we're adding rational expressions, and we have to get a common denominator. All right, so we'll do that. All right, first we look at the coefficients, and we ask, what's the common denominator for 10 and 15? All right, so that would be 30. 30 is the smallest number that 10 divides into and 15 divides into. All right, and now we're looking at x cubed and x fourth, and we just take the higher power, that would be x fourth. And y squared and y, again, take the higher power of y squared. And there's our common denominator. Now, what do we have to multiply 10 by to get 30? Well, that's 3. And we have to multiply x cubed by x to get x to the fourth, and y squared y squared. That doesn't change. So we're going to multiply top and bottom by 3x. Okay, and now what do we multiply 15 by to get 30? Well, we multiply by 2. X fourth doesn't change, and we have to multiply y by y to get y squared. So we're going to multiply top and bottom here by 2y. Okay, so we have 9x for the first numerator and 4y for the second. Now we have a common denominator, so just put 9x plus 4y over the common denominator, 30x to the fourth y squared. All right, so now you're ready to do 3. Here's exercise 3. Let me just scroll that down a little bit. Okay, so pause the video, copy it down, and do exercise 3 now. In number 4, we're again adding rational expressions. We want to get a common denominator, but we have to factor first. All right, so let's factor this denominator by pulling out x squared. So we have x squared times x minus 1. And here let's start by pulling out x, and we get x squared minus 2x plus 1. And then we could factor x squared minus 2x plus 1. That's x minus 1 times x minus 1. I'll write that right away as x minus 1 squared. So we're looking at these two factor denominators to get the common denominator. All right, now the common denominator is going to have a factor of x, a factor of x minus 1. That's what they both have. And just choose the higher exponents for each factor. So for x, we're going to choose x squared. And for the factor x minus 1, we're going to choose also x minus 1 squared. All right, so that's the common denominator. All right, here we're missing a factor of x minus 1, so top and bottom gets multiplied by x minus 1. So we have 2x minus 2 in this numerator. Here we're missing a factor of x, so just multiply top and bottom by x. And we have a 3x in this numerator. And now we're ready to add, copy over that denominator. And for the numerator, 3x plus 2x is 5x, 5x minus 2. Okay, so now you're ready to do, let's see, the next example, which is 4. And there it is. And let me just scroll down a little. Make sure that you can see that. Okay. So there's question 4. So just pause the video right here and combine these two fractions. In number 5, we have what we call a mixed quotient or a complex fraction. We want to get rid of these denominators just to simplify things. So we're going to multiply top and bottom here by the common denominator of between 6x cubed and 12x squared. All right, so between 6 and 12 we have a common denominator of 12. So we'll multiply by 12, and x cubed, x squared, we're going to multiply by the higher power of x cubed. So we want to multiply top and bottom by 12x squared over 1. Sorry, 12x cubed over 1. So that these denominators will cancel out when we multiply through. So what we do in the first step is we just set it up. Okay, first 12x cubed times 3, that's 36x cubed. And here I'm just going to put 2 over 6x cubed next to 12x cubed over 1, and I save canceling for the next step. Again, just set it up in the denominator 5 over 12x squared multiplied by 12x cubed over 1 minus 3 times 12x cubed, that's 36x cubed. And now for some canceling. 6 goes into 12 2 times, and these x cubes just cancel. The 12s cancel over here, and here x squared, x cubed, we're left with an x. Alright, so now let's just write down what's left. And we have 36x cubed minus 4. And then the denominator 5x minus 36x cubed. And that's our simplified result. Okay, so now you're ready to do number 5, which is right here. Alright, so you can pause the video and copy this down. In example 6, we're multiplying two radical expressions, and we multiply underneath the radical symbol, and we're going to multiply the numbers outside the radical symbol. So we'll have 2 times 7 is 14, then underneath the radical 18 times 2, that's 36, and x times x to the 5th is x to the 6th. Both of these are perfect squares, so we can take the square root. So we have 14, square root of 36 is 6, and the square root of x to the 6th we get by just taking half of that exponent. So that would be x cubed. Alright, so it's 14 times 6, that's 84 x cubed. And now we're ready to do number 6. It's right here. Alright, so copy down number 6 and do that problem now. Alright, let's look at example 7. We're dividing two radicals, and we're going to just divide underneath the radical symbol. So let's do that. So here we have 2x cubed divided by 50x. And let's do some reducing here. 2 into 50, that's 25. And x cubed in x, we get x squared in the numerator. Okay, so we have the square root of x squared in the numerator and 25 in the denominator, so that's x divided by 5. Alright, so now you're ready to do number 7, so copy that down, it's right here. Alright, hit pause and copy this down. In exercise 8, we want to reduce this radical. This is a cubed root. So we're looking for a perfect cube that's a factor of 24. Alright, so let's remember our perfect cubes. We have 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Alright, so 8 times 3 is 24, so 8 is the factor that we're looking for. So we write 24 is 8 times 3. Now what about x to the 14th? Well, that's not a perfect cube because 3 doesn't divide into 14. So we'll go down to 13. Okay, 13 is also not divisible by 3, so go down to 12. Okay, 12 is divisible by 3. So let's write x to the 14 as x 12 to the 12th times x squared. And here's what we're taking out. We're taking out an x. That's our perfect cubed, and this is another perfect cube. Cube root of 8 is 2. Cube root of x to the 12, just divide that exponent by 3, and we get x to the 4th. Alright, so now in front of the radical we have 2x to the 4th, and underneath we have 3x squared. Alright, so that's reduced. So now you're ready to do problem number 8. It's right here. Copy it down and do problem 8 now. In example 9, we want to add two radicals, but first we have to get common radicals, so or like radicals, so we're going to simplify. And let's start with square root 45. All right, so that would be, that simplifies as 9 times 5. All right, the 9 is a perfect square. We're going to bring that one out. So we want 125 to simplify and leave us with a 5 underneath the radical. Well, 125 is 25 times 5. And 25 is a perfect square. Square root is 5. 5 times 2 is 10, so we have 10 square root 5 plus 3 times 3 is 9. 9 square root 5. And the sum here is 19 times the square root of 5. Okay, so now we're ready to do number 9. Okay, here's problem 9 right here. Copy it down and do number 9 now. Finally, in example 10, this is our last example, our last quiz example. We're going to multiply top and bottom by the conjugate of the denominator. We want to rationalize this denominator. Those are the instructions to rationalize the denominator. So we have to multiply by the conjugate, which is 2 root 5 minus 3. So let's do that. 2 root 5 minus 3, top and bottom. All right. Let's put some parentheses here because on top we're doing a FOIL multiplication. And in the denominator we're just multiplying conjugates, which is a little easier. Just doing first and last because outer and inner cancel. So first we get 4. 2 times 2 is 4, and root 5 times root 5 is 5. So we have 4 times 5. And then 3 times minus 3, that's minus 9. So we have 20 minus 9 here. Now let's do the numerator. We're going to do a full FOIL multiplication in the numerator. Root 5 times 2 root 5, that's 2 times 5. That's the first. Outer, minus 3 root 5. Inner, plus 4 root 5. And finally last, 2 times minus 3, that's minus 6. All right, let's rewrite here. Here we have 10. This is 10. 10 minus 6, that's 4. And minus 3 root 5 plus 4 root 5, that's plus 1 times root 5. 20 minus 9, that's 11. Okay, so there we've rationalized the denominator. Now the denominator is a rational number. See, that's rational. Okay, so you're ready to do the last problem on the quiz. That's question 10. There it is. Okay, so copy it down. Question 10. And finish off the quiz. Okay, good luck.